In the proposal, you show the client that you understand their organization and what the project entails. But you actually have to try to understand the project through either field trips, interviews with SMEs, the subject matter experts, readings, exploring the data. I know that I've alluded to this, but let me say it again. Sometimes even just trying to get the data can prove to be a massive pain in the butt. The thing with the client is that it's not typically a uniform entity. Even though you're being brought in to do some work for them, it's quite conceivable that both data specialists and SMEs will actually be resentful that an external consultant has been brought in. This is your chance to show them that you are on their side. You ask meaningful questions. You take an interest in their experiences, and you have to acknowledge the fact that they are able to help you, and without their help, you might get nowhere. It is a fact of quantitative modeling that whatever action you will end up suggesting that the client takes is derived from some reduced form of data, which is itself obtained by processing and reducing raw data, which is typically obtained through the help of sensors, data collection principles, data collection methods, and some conceptual model, which in general is not explicit, but it should be explicit, which is meant to be a representation of the part of the world that you're studying, which is itself a subset of the world or the universe as a whole. When you're quite to the left, you are in the world of detail. The universe as a whole is very detailed. When you move to the right, when you reduce the data, you enter the universe of rigor. Trying to extract knowledge from data requires rigor. But keep in mind, and this is crucial, going from this layer to this layer, you lose a lot of detail. You lose connections. You're hoping that this representation of the universe, of the world, of the part of the world you're studying, is close enough to the reality that it doesn't matter that you've made simplification assumptions. And this layer here, the conceptual layer, is actually quite different from the data layer. The data layer is a representation of the conceptual layer. Again, by necessity, you will have lost some information. It is not the full picture. Going from the raw data to the reduced data, you again lose some information. And going from the reduced data to the insights, you will again lose some information. At every step of the way, you make simplification assumptions, or you use the modeling result as a representation. Are the simplifying assumptions too steep? Is the insight that you will extract from the process still connected to the reality of the universe? This information that you're collecting is going to help you actually decide whether the data you're working with allows you to solve the problem that the client actually wants solved. It is not a given that it will do so. In many instances, we work with the data that we have because that's the data that we have. You might have heard people say, this is the best data we have. Well, if the best data we have doesn't allow us to talk about the aspect of the world of interest, we may not actually use it. One of the challenges we have when we work with other intelligences, other agents, we need to have a shared understanding of what's being studied. When people talk about thinking in systems terms, they mean that we understand the objects and their properties that make up a system and how they might evolve over time, and how actions, and how within that system there are actions and evolving properties that allow us to think in terms of processes. The objects have a bunch of properties. The processes will generate or potentially destroy objects, and they may change the properties of these objects over time. When we collect data, what we do is we observe, we quantify, we take a measurement, particular values of the properties at specific points in time. We don't usually do so continuously. So we generate a data set, which is meant to represent the underlying reality of interest, but it does so with a degree of accuracy and error. And the error may be biased or unbiased. Sounds great in theory, but in practice what it means is that whatever we end up working with is an approximation of the true phenomena we're trying to model. I've heard it said before that the only valid model of the universe is the universe. So that whenever you represent the universe through a simpler system, you automatically lose information. If you're just trying to model a bit of the universe, say a hydrogen atom, perhaps it doesn't matter that you've lost a lot of information about galactic structure. But if you want to get a model of the whole, you need the whole. Is the approximation still useful? Along the way, we may discover that we have gaps in our knowledge. When we realize that what we, or the experts, thought we knew about the system is actually incomplete or flat out false. But this could happen at any moment in the process of simplifying, of going from the universe in all its glorious detail to a single bit of actionable insight. There might be knowledge gaps everywhere. It could happen when you clean the data, it could happen when you consolidate the data, it could happen when you analyze it. You have to be flexible. When you're faced with such a gap, and it will happen, when you realize that the data doesn't behave the way you thought it should, but it's also conceivable that there's a problem with the way you understood the system to work. Go back, ask questions, either of the subject matter experts or of yourself, and modify the system representation. The first step in the representation process is to build a conceptual model of the situation. You do that with the help of methodical investigation tools. So you go out and you jot down diagrams. You do structured interviews and structured descriptions using ontological tools. You try to make every assumption about the model explicit. You have to be very weary of implicit conceptual models. If you're all working on an implicit conceptual model, one that is never explicitly stated, it is quite likely that you're not all actually picturing the same thing. And then you can get lost in translation. You're not speaking the same language. You're not speaking about the same things. There's also the issue of relating the data to the system from which it arose. Is the data that you've collected and analyzed going to be useful for understanding the system? You can truly only answer that if you understand how the data is collected, what is the approximate nature of the data within the system, and what the data is meant to represent. Is the combination of the system, so the explicit model, and the data that we've collected sufficient to understand the aspects of the world that you're studying, that the client wants studied? If the data, the system, and the world are out of alignment, that any insights you achieve will ultimately prove useless. There will only be insights about the data that you've collected. Just as the analytical workflow is not a linear step-by-step process, going from the universe to actionable insight requires multiple passes. And I'd be very puzzled if you never hit a knowledge gap along the way.